Good afternoon. Good afternoon. Um, Welcome to tutorial session number 2 for MTHS 172. Before we start, can I ask everybody to change their names to their student numbers for attendance register purposes? Once that is achieved, you can start the session. All right, I can see many of you have changed your thingies. Thank you very much. I'd like to welcome you again to the second tutorial for MTHS 172. If it happens that you got in this tutorial session and you are not a student of MTHS 172, you are given the permission to leave. But all right, let us start working, guys. Yesterday we did a session on what do we call this? We did a session on area between two pairs. Today I wanted to do a session on THS 172 tutorial. Okay. Today I want us to do a tutorial on arc length. As you have seen in that tutorial sheet that the lecturer posted yesterday, there is problems on arc length. So I would like us to start with arc length. Since it is the smallest or the shortest, then we are going to be able to move onto the surface of a revolution. I hope you all can see. I hope all of you can hear me. If you cannot, please let me know such that I can be able to fix my things this side. Okay. So I'll take it as your guys can hear me. Yeah, I'm very happy to see progress. Okay, so I want us to know, or to however understand, one of the most important equation when you are going to solve for that. And the equation is as follows. Oh my God, what is this? Okay, I'm having a problem. Okay, that's about it, guys. What's going on? Guys, having a problem. Having a problem. Okay, back. Okay, so I was still talking about the equation of the arc length. Yeah? The equation of the arc length is given by, or is denoted, or it is derived to L is equals to the integral from A to B of the square root of 1 plus f prime at x, and this should be squared dx. Okay, so only the f prime part is square. This is when you are given this thing in the x-axis, and when you're given this thing in the y-axis, it's still this thing a b. Okay, let me use something different because you might think that a. Let me use c and d. C and d is the root of 1 plus f prime at y squared dy. So I said dx, guys. That's the mistakes that we're committing. And then this one is the one that we're going to deal with in the y-axis. So guys, it is important for you to understand. Yeah? Okay, let me just write it neatly along the x-axis and along the y-axis. Okay. So with the length of a curve, guys, there's nothing much that you actually need to what do this cram or try to understand stuff. Only if you can understand this equation, then you are done. There's nothing much because you don't need to draw, you don't need to do anything. You just need to know how to apply integration. So I find you there, here, guys. If you're not fine, and if you feel I'm moving too fast, please let me know such that I can be able to assist you accordingly. Okay. So, for the purposes to ask at any let me try find some question. Okay, I click on your tutorial. Find the outlet. Okay, let me try and get some examples. Some nice. Where is the example? But so far, guys, yesterday's session, with everything that we did, we were able to solve the problems in the tutorial sheet. Because if it happens that you try to solve it, you need to make me aware such that I can be able to help. So guys, please unmute yourself and tell me how was it in terms of solving the problems. Were you able? Were you not? What can I do to assist you and stuff? That is if you had any problems. Oh, so I can assume that all of you understand the thing. Because if you all guys are this quiet, you means you understand that thing very well. So in that case, I'll say I'm happy. I'm very happy to see you guys doing these things very well. And on Monday's test, I know you guys are ready for the test. And I know also that I can't find some. All right. Find the arc length of the graph of. Okay. So let's have the first example. So guys, I really hope that you guys are going to be ready for the test on Monday. And this session will somehow help you some of the things that you're expected to know. Yeah. Let's say they say you've got y is equals to x cubed all over, let me say 6 plus 1 over 2x on the interval x is an element from half to 2. Yeah, I feel like this one. Okay, so we've got a problem here which we need to solve. Okay, so we've got I don't think I should draw this function because it's not really the best to, but okay, so once you start having something like this, because it's only a specific function, you don't need to know where it is continuous or not, because usually when they give you this interval, they give you an interval of the part where the function is continuous. And then the first thing that I am going to do here is find the derivative. Y prime, some can say dy dx. This will be equals to 1 over 2 x squared. 1 over 2x squared plus, so it's going to be minus, so I'm going to have negative 2, 1 over 2x squared, 1 over 2x squared. Okay, so I'm going to have something like
What's
this.
going on?
What do you mean?
I don't understand anything.
You don't understand, or you don't see, or
I don't understand what you're doing.
oh, sorry guys, my network is very bad. It's like, oh, so you're saying that you don't understand what I'm doing? Where in this step?
Yes.
Oh, here I'm trying to find the derivative of this function.
Of the 6.
You see the derivative? Yeah, this is x cubed over 6 plus 1 over 2x. So I'm trying to find the derivative of this.
Okay.
Are you with me now?
I think so.
Okay. Okay, let me try and do this then. Okay, so guys, please forgive me. My network is very terrible. I don't know why, but it keeps on jamming. Yeah.
I'm scared, may I ask?
So is it better now, guys? Is it better now? If it's not better, please let me. Yeah. Okay, so as I was saying, I started by finding the derivative of this function. Yeah, and with the derivative, I'm finding this. So if you guys find anything different, please do let me know, such that I can be able to yeah, see if whether what I did is wrong or it's right or what. Yeah. So for now, let's just continue. Okay. So we're gonna have something like 1/2 x squared minus 1 over x squared. Okay. So this is the derivative that I am finding. I don't know if whether it's true or not, but yeah, I will trust that this is true since nobody has is proving it. So right. So I'll trust this is true. So after finding the derivative, we are now going to take that value of the derivative and substitute it to our equation. Yeah? So what we're going to have is, since the value of a is given by 1/2, the value of b is given by 2, we're going to have the arc length as the integral from 1/2 to 2 of the square root of 1 plus 1/2 x squared minus 1/2 or 1x squared, and this part is squared dx. So far, are you with me, guys? If you are not, please let me know such that I can do that again. Okay, so I'll take that as a, yeah, fine. Okay, so as I continue, why is this very much disappointing? As you continue, I'm gonna have 1/2 to 2. Then we're gonna solve this part, guys. Yeah? With the solving of this part, guys, I know you know how to solve it. And with regards to that, do you give me permission to skip a certain step here, or should I show you how I'm going to do the whole stuff? Because in any way, but let me not skip any step. We are gonna have 1/2 x squared minus 1/x squared, and this whole thing is squared. So according to the rules, we know that we can rewrite this as 1/2 squared x squared minus 1/x squared squared. This will give us 1/4, and this will be, let me see, x to the power of 4 plus 2 plus 1/x 4. Yeah. So do you all agree that when we have this, you can't hear it. Let me try and fix this, as my network is terrible. About this. Very sorry. Okay. Oh, so you just this part you can't do. I understand why. Okay, other thing is that I'm gonna take the part alone and have the 1/2 and say, okay, I see, and you may proceed. Okay. Guys, please let me, because this thing that I have right here is slow. I don't know why. NWFI is not working out to it. So yeah, I will try to do whatever that I have. My data is even more. Right, let me go back to my file. It's okay. Okay, so sorry about that, guys. I was still trying to check which one works best. Is it data or Wi-Fi? But data is worse. So yeah. On this part, guys, I said to you, I'm gonna take the part where I wrote 1/2 x squared plus 1 over x squared. Is it minus or plus? What's minus? Minus. And everything is squared. And I said to you guys, I'm gonna write this as and my guide cannot oh sorry. The person who's saying says so the root is not gonna cancel the square root. No, it's not. It's not gonna cancel the square root because the square only applies for this part, not the whole part under the square root. If it was the whole part under the square root, then it was gonna go away. It was gonna, yeah, it was gonna cancel out in that way. But since 1 plus this thing is not squared, 1 is not squared, the plus thing is not squared. So therefore, these are two different terms under the square root. Therefore, they cannot cancel one another. Hence, we are doing all of this stuff. Okay, so we're gonna have 1/2 squared, and then we're gonna have x squared minus 1 over x squared squared. Okay. Okay, thank you. Yeah, very. Okay, so now what we're gonna have here is 4th, because 1 squared is 1, 2 squared is 4, and then what you're gonna have here is going to be, okay, so I'm gonna have x squared minus 1 over x squared, and I'm gonna have x squared minus 1 over x squared. So let me just make it a bit longer such that we can all understand. So I'm gonna have x to the 4th, this times this times that is gonna be -1, this times that is gonna be -1, this times that is going to be plus 1 over x to the 4. Okay, so oh no, made a mistake in the first one. So that's what you're gonna have, guys. That's what you're gonna have. So on this part, I'm going to have 1/4 x to the power of 4 minus a 2 plus 1 over x to the power of 4. Okay, we can multiply throughout by this, and we're gonna have 1 over 4 x to the power of 4. This times that is going to be -2 over 4, which is 1 over 2, plus 1 over that. Okay, or 4. Okay, so this is what we have for the part under the square root. But what I like to do is, I would like us to say whatever that we had, because we had 1 plus the whole thing under the square root, x squared minus 1 over x squared squared. So I want us to introduce the 1 in this equation that we have just copied. What I mean is that we're going to have 1 plus, I'm going to have that 1 over 4x fourth minus 1 over 2 plus 1 over 4x to the power of 4. And you can see that this and this will just give us 1/2. So I'm going to have 1 over 4 x to the power of 4 plus 1/2, because 1 minus half is just 1/2, plus 1 over 4 x to the power of 4. And there's something which is common here, which is 1/4. Yeah? So a quarter, and I'm going to have x to the power of 4 plus a 2 plus 1 over x to the power of 4. Because when I multiply this and this, it will give me 1/2. Yeah? When I multiply that, it will give me 1/2. The reason I'm doing all of this is because I want this thing to be very easy for us. We should not deal with the hard things here. We are easy students. We cannot be dealing with hard stuff. So do you all understand how I got this, guys? I was gonna skip all this step, but I see maybe it might help some. It might be advantageous. Okay.
Sir,
Yes. Please
can
talk to
you
me.
please explain from 1 over 4 x to the power of 4 minus half plus 1 over 4x to the power of 4.
Okay, so I've got two questions now.
Yes.
So Okay, my man, I will answer you just now. And then there's somebody who sent, and the person said, I still don't understand your second step. Which second step? This one or this one? Then please make me aware which step you're talking about. Please unmute yourself and tell me which second step you're talking about, such that if you guys have got the same question, I can answer it once, or I can redo the whole thing. So the person who says they are having a problem with understanding the second step, please unmute yourself. Okay, so since that person doesn't want to unmute themselves, I will just deal with yours, Bokang. Because Bokang who asked this one. You are saying you don't understand where? Yeah.
Where? Yes, from there, going downwards.
Oh, yeah. Yeah. Okay. So you remember what I did, né? At the beginning of my step, I said, I'm going to take only this part and then expand it. Yeah?
Yes.
So as I was expanding this part, I got this solution. Yeah?
Yes.
I said, because under the square root, we still have got a 1 plus that part that we expanded. Might as well put that 1. You understand it?
Yes.
Yeah. So what I did was I introduced that 1. And I said, okay, under the square root, we've got 1 plus the whole thing. But this thing, we've got its expansion, which is that. So why don't we just say 1 plus that expansion will give us exactly what we have? Do you agree?
Okay, yes, I do.
Okay. So now what I did was I simplified the whole thing, including the 1. Is that 1 plus the expansion of this part. So I got the solution. Do you understand it now, or should I redo it?
Yes. Yes,
Redo or understand?
I do understand.
Okay. Thanks, man. Thanks. Okay, is that the only question we have, guys? If so, let's continue. All right. Oh, we're running out of time. Okay, so guys, this thing is gonna go off in 10 minutes. So I need you guys to use the same link to return back to us. Oh yes, my guy, talk to me. What is the question?
Can you please repeat your second step?
This one.
No,
This one.
Kadin. Your second step. That's all.
Which one? This one.
Yes.
You saying I should do? Okay.
Repeat it.
Let me repeat it. Okay. Let me write it at the back. We had an equation of y is equal to x cubed all over 6 plus 1 over 2x. Né? And I said you find the derivative of this. Né? We said the derivative of this is equals to whatever is which is going to be 2x squared over this plus here we're going to have 1/2 x to the negative 1, right? When we subtract 1, when we subtract 1, we need to multiply by whatever that we have here, which is negative 2, right? Are you with me, my brother?
Yes.
Okay. Oh, you are trying to show me an error that I did.
Yeah.
Oh, I didn't see that one. I really didn't see that one. Ah, okay, no, it's fine. So what I'm gonna have here is, wait. Oh yeah, I made an error. So it is going to be x squared over 2. No, wait, it must be 3. No, oh, there's no error, my man. Yeah, you know what I did? Yeah? I made a mistake, me, because You remember when we were doing differentiation, we said when we differentiate d dx of x to the power of n, we're always going to say n multiplied by x to the power n minus 1. I didn't do any mistake. Because when I think about it now, I actually thought I made a mistake, but I did not make a mistake. Now look at this, my man. Y is equals to x to the power of 3, 6 plus 1 over 2x to the negative 1. We are just going to multiply this here. We're going to have 3x squared over 6. And then we're going to multiply this here. We're going to have a negative, right? Because it's negative 1 over 2x to the negative 2. This is how it goes. So I'm going to have 1 over 2x squared minus 1 over 2x squared. Do you see that, my man?
Yes.
I did not make any mistake. I used this idea of differentiation. So when you were saying it here, I was very confused. Okay, what am I doing now? Because this is not mathematical. Yeah?
So I do understand now.
You do understand it now. Eh? Okay.
Yeah.
So there's a person who says they don't understand a step. Please unmute yourself and tell me which step you don't understand. The person is Miss T. My lady, please unmute yourself and tell me which part you don't understand such that we can be able to. Okay, so since the lady does not want to appear, it's fine. As we continue, the arc length is given by this equation. You remember this equation, right? And now we have solved this part. But there's something beautiful about this equation. I want to show you something. We can actually factorize this part. Yeah, we can actually factorize this part. And with factorizing this part, we are going to get something of this nature. We're gonna get, because this thing is like that, so we're gonna get 1/2 or 1/4, and I'm gonna get x squared plus 1 over x squared. Now, where does this thing come from? Ne? Where does this part come from? I use the same logic that we used here. You remember this was x squared minus 1 over x squared. But in that case, we had a negative 2. This thing looks exactly the same as this one. It's just that here we've got a positive 2, meaning that we are just going to have a plus instead of this minus that we had here. Do you see that, guys? Ne? If you don't, please let me know such that I'll be able to help.
Yes, sir.
All right. Thank you. Thank you very much. Ne? So, which means that as we return back to our integral, the arc length will be given by 1/2 to 2 of the square root of, we got 1/4 x squared plus 1 over x squared. See that both these terms are perfect squares. Like when you put them under the square root, we're going to get solutions which are going to be whole numbers. Define a perfect square. So the square root of this, 1/4 multiplied by the square root of x squared plus 1 over x squared dx. So you're gonna have the square root of 1/4 is just 1 over 2 to 2, and then have that thing, which is x squared plus 1 over x squared, because now this thing and that thing would cancel out, and then you're gonna have dx here. So what you're gonna have here is 1/2 that 2 x squared dx plus, now I'm gonna change this and say 1/2 2, or let me introduce this, 1/2 2, and then have x to the negative 2 dx. From here, guys, I know you can integrate. Can you, guys? Okay, so the solution will be something like 1/2 x cubed over 3. And then here we're gonna have negative x. We're gonna have something like this from 1/2 to 2. Okay, so this is the integration. This is what we get after integrating the whole thing, guys. This is what we are going to get. So if you guys are terribly quiet, which makes me not sure if whether you can understand. Yeah, but this is what we're going to get. You guys will let me know. So I'm gonna have 1/2. Now we're gonna substitute. So we're gonna have 1/3 of 2 cubed minus 1/2 cubed. And then you're gonna have minus 1/2 minus half. So what is the solution that we get? Oh, sorry, you don't see me. Sorry about that. That's just direct substitution. So what is the solution? Okay, sorry about that. Sorry about that. Let me see. So over 2. 47